Okay, so let's try some examples. Let's simplify a rational expression. We can take a look at 2. So steps, you want to simplify, and then you also want to state non-permissible values. Okay, so let's start by simplifying. What we want to do is factor as much as we can. So if we take a look at the numerator, we have a GCF of 3, so we're going to factor a 3 out, and we are left with 3 times x minus 2. And in the denominator, you have a trinomial, which factors to 2x plus 5 and x minus 2. Okay, reduce what you can. Okay, so we're going to reduce x minus 1, x minus 2 goes into itself once, x minus 2 goes into itself once, and we are left with 3 over 2x plus 5. Okay, and non-permissible values. Well, we take a look at both of our denominators, and we say that whatever 2x minus 5 is, plus 5, it can't be 0. So when we simplify that, we get that 2x cannot be negative 5 over 2. And also, whatever x minus 2 is, it can't be 0. So x can't be equal to 2. So we go back up here, and our final answer is that when we simplify, we get 3 over 2x plus 5, where x cannot be equal to negative 5 over 2 and 2. Okay, let's take a look at our next example. We've been asked to reduce, to simplify 1 minus t over t squared minus 1 and state the non-permissible values. We're going to use 2 methods. Okay, the first one we'll use factoring by negative 1, and the second one we'll use the property of 1. So let's start. We're going to take our expression, and we're going to factor the denominator. Notice it's a difference of squares. Okay, and a difference of squares factors into a sum and a difference. Okay. All right, now, if you take a look at our numerator and compare it to our denominator, oh, how did I go to x's? Let me do that over again. That should be t's, right? Okay, t and t. Okay, and compare to this part of the denominator. Okay, so if you take a look, you've got t minus 1, where 1 is positive and t is negative, but in the denominator, you have t minus 1, where t is positive and 1 is negative. So when this happens, what we want to do is we want to make sure that we can take one of those binomials and factor out a negative 1 so that they have the same value. Okay? So I'm going to take a negative 1 out of the numerator, and I'll do that over here in the margin. Okay, so if I have t minus 2, and 1 minus t, and I say that I have a common factor of negative 1, then you're going to go, well, 1 divided by negative 1 is negative 1. Negative t over negative t is positive t. Okay, and so you can rewrite that where it reads negative 1 times t minus 1. And now notice that your t minus 1 matches the t minus 1, which is in the denominator. Okay? So we're going to go back, go to our numerator, we're going to take out a negative 1, and we get negative 1 plus t over t plus 1 times t minus 1. Okay, so the purpose for doing that again is to make sure that the expression in the numerator matches the one in the denominator. Okay, so that we can reduce them. And so if you like, you don't have to do this, but if you like, you can rewrite negative 1 plus t as t minus 1 over t plus 1 times t minus 1, and then you can reduce. Okay, so t minus 1 goes into itself once, t minus 1 goes into itself once, and we get negative 1 over t plus 1. Alright, so non-permissible values. Alright, in our denominator, we have two binomials. The first one, t plus 1, cannot be 1, so t can't be negative 1. And t minus 1 can't be 0. Sorry, that should be 0. Okay, and so t can't be equal to 1. Go back to our answer, and we say that our answer is negative 1 over t plus 1, where t cannot equal plus or minus 1. Okay, now let's take a look over on the side here. We're going to factor the denominator. Realize that the numerator is the opposite additive inverse of one of the factors in the denominator. Okay? So that means that 1 minus t, and let's put is, the additive inverse of what's in the denominator, which is t minus 1. Okay, so all that means is that their signs are opposite, right? Where in this expression the 1 is positive, it's negative here, and where in this expression the t is negative, it's positive here. So when you see that, one of the ways that you can address it is to factor a negative 1 out of the numerator. Okay, that will make both of them the same binomial, the signs the same, right? Okay, our second method is to use the property of 1. What that means is you want to take the original expression, and we'll take the factored form because we've already done it. Okay, so we've got 1 minus t over t plus 1 times t minus 1. And all we want to do is multiply the numerator and the denominator by negative 1 over negative 1. Okay, and we can do that because the value of negative 1 over negative 1 equals 1, right? Anything divided by itself is 1. So we're really just multiplying by 1 and not changing the expression. Okay, so if I take my negative 1 and multiply my numerator by that, I'm going to get negative 1 plus t. Notice it changes the signs. And then I'm just going to put the negative 1 in the front of what I have in the denominator. I'm not going to expand because I don't want to change the signs. And notice now that my numerator and one of the factors in my denominator is now the same. Okay, my 1 is negative, my t is positive. So I can reduce those. And I want to bring the negative 1 into the numerator. And so my final answer is negative 1 over t plus 1. We've already done our non-permissible values, so where t cannot be equal to plus or minus 1. Okay, so let's go over to the side. Factor the denominator, which we've done. How are the numerator and the factor t minus 1 in the denominator related? 1 minus t and t minus 1 are additive inverses. Okay, when that happens, you can multiply the numerator and the denominator by negative 1. Okay, and then that will make sure that these two binomials will share the same signs. Okay, so let's move on to our last example.